popular, that much of what do you call future proof right now. So we will be using testings in basics terms. Okay, there is just mean karma. Based on your service, you can use any other things as well. Okay, but since this is test suite is set up for us by NX, we don't need to and do anything else. So when we are working with testing libraries, there are certain capabilities they provide, especially when we are writing a unit test or any other kind of test. There are some places we need to depend on something else. Okay, so if we are depending on something else, we need to have that dependency resolved before we get testing out. Okay, but the problem with unit testing is that the unit tests are solely independent. Okay, so if you are writing a test case for a method, that method, if there is a dependency on other methods as well, first thing is that we should not depending on any other methods. That's what do you call that's violate the unit testing principles. It should be executed independently. But in case we are testing something chained or something more complex, there can be exceptions in that scenario. So let's say, for example, you are testing a compound method. That means a method containing 2 or 3 methods. Okay, a result of 2 or 3 methods, the final method is executed. So in a scenario like that, you are not going to test each and every within functions. That's because it's defy the purpose of writing a unit test. Unit test only focus on writing a one singular function. That function should work. So if there are any dependencies, we should be able to mock the other functions behavior. That means we are not going to write test on each and every step. Other methods should have their own test. But in a scenario where we want to pass the test, we will be mocking these methods. Okay, we will see how we can mock these methods that we can write a compound test. But mocking capabilities we should not invent ourselves. Okay, mocking capabilities should be provided by the framework that we're going to be using on. Okay, so there are certain features in Jest. We call those things spy or spy methods. We will look into this. We will look into those. So you will get an idea. Okay, how do we will mock a method like this, and so on and so forth. So mocking capability should be there. And in a test, there are certain way of testing is there. The other thing that we should have within a testing library is check whether it is the value it's supposed to be. Okay, what do we understand by testing? Testing is checking whether when a certain input is given, the certain output is also received. Okay, so when we give certain inputs, certain output should be there. Okay, that can be something like that. Okay, when I give these two numbers, it should be equal to this number. when I give these two numbers, I'm setting a hypothetical example here. When I give these two x and 9 numbers, it should be greater than this number. It should be less than greater number, or it should return always 0, or it should return an error. Okay, so that kind of things we call assertions. Okay, and if you guys can see in here, line 20, it is also called an assertion. Okay, we are saying something and we are asserting whether it is the value that we are expecting. Okay, so assertion happens. Assertions library should be provided within the test library. Otherwise, what we have to do is we have to do it ourselves. So to avoid that, what we can do is we can have assertions. Okay, we will be using assertions. So there are other things as well. Most of the time there is something called code coverage. That means when you are writing code, whether you have write enough or sufficient test cases for that is calculated by something called a code coverage. Okay, there is built-in tools for test suites. Okay, checking whether there is a familiar or there is a test case written for our business logic. There are generators for that. So there is test coverage tools built in there, like that. So most of the time you will have things built in to your application, but it's not. We can find it always within our applications. Okay, and yeah, let's try. So setting up the jest is done for us, but if there are any configuration changes that we need to happen, the default is always there. But if you find yourself you need to change the way jest works, of course you can go to this jest configuration. You can change, and there are a couple of configuration files which are not seen in here, but you can always override and customize. Sometimes default test setup is not what we want. So in order to change those things, you can always go into configuration files and change these things, but most of the time we'll be sticking up with what we have. Okay, all right, next thing is we'll try to write a simple unit test. Okay, let's see whether we can get an example out of basic testing. Let me check whether I have. Dun, 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 dun. So anyhow, do you know, guys, the testing life cycles normally? Anything about testing life cycles? Otherwise, you will be stuck with some basics. In here, you can also see. No. Hello. You guys have any idea on testing life cycles? Silence things. I think you guys have no idea. So as I mentioned earlier, when we are writing a test configuration, what happens is we need to make sure um, we need to make sure that that the that the test is ready for execution. Okay, so for example, we will be testing the profile component. Okay, so before we run this test, we should make sure the profile component is created without an issue. Okay, it is created with all these dependencies. Right now with the profile module, profile component is one simple thing. We don't have any dependencies, but in other case, any case, we have to make sure this component is created for testing. Okay, so we have this before each syntax, or before each coding standard. That means we can have multiple tests. So you can see in here, it represents one single test case. Okay, so we can execute this test, but before each one of these tests get executed, we are creating a brand new test declaration, because the reason is behind writing unit test. It can have what do you call, caching mechanisms, or it can once we create a profile component, it might affect the other test case. So we are always executing these tests right before or right after we create a brand new component. Otherwise, what will happen? Some older version of the component might get stuck, or sometimes there can be caching. So everything can be like really hard to work with. Okay, so we have to find life cycle methods. Okay, the before each life cycle method will be executing before each and every these tests get executed. Okay, if we can have multiple test cases, before each and every one run, this execution will happen, and it will create a brand new component that we can run our test on. Okay, all right, we'll start it here, and we will move forward, and that will make things easier. So let's start with the basics. So you can see that there is a keyword called describe. So describe is what we call a test suite. Okay, it's a collection of tests. Okay, so when we are executing a group of test cases related to one another can be grouped together. So that is called the that's what we call a test suite. So in here, we will be describing the profile component. So we can have another describe component which can contain a set of other instructions. So within a describe function, we can have multiple describes as well. If we have say for example, within the profile component, we have another component, we have another section that we can group together. We can put it in a describe block and we can execute that. Okay, so it's easy to group things, and we can focus on what we will be seeing. So in here, we will find the describe description for profile component, and as I mentioned, the lifecycle methods. We'll be creating each of this profile component every time before we run this application, and it's easy to check whether it is done. So these lifecycle methods, they don't really have a name. It's just there for our reference, and the way that these components are created, we are calling these fixtures. Okay, these we have to, otherwise creating this component involve creating this module and everything, but we can skip all those things. We can use this tool within Angular itself. We call this testbed. Using testbed, you can easily create a testable profile component. Okay, this is how we do it. You have to say testbed configure testing module. Okay, we have to declare a modules. So if you go to the module section and declaration, it's going to be something similar to this. Okay, so we'll be having that in here. So when you are adding more dependencies, you will see it's really frustrating to have some things like this common module and routing module. They are like basic imports, but if you have material inputs or any other UI library that we will be importing, you have to configure it in here. Let's see when we advance on, we will see how we can do that, and a lot of errors will be coming there. And using a fixture, this is the component fixture. We will create what do you call a dummy component. Okay, using test beds, and the component will be the component instance. Using this fixture is like what do you call a fixture is like how do I put it in component fixture? It's like creating a mocking instance of this, and we will get a testable instance. Okay, that's the simplest thing that we can do. We can say like using a fixture, it is like creating a dummy component that we can use. Okay, we can get the instance itself, component itself, by calling fixture and get component. And fixture detect changes. If we have not defined this, the execution will not happen. That means the testing, the change detection, JavaScript execute on a different life cycle, like on init. In Angular we have on init and all those things. So unless we start detecting changes, the test execution will not happen. Okay, so we need to detect for changes. When detection happens, then and only then we can check for the application changes itself. Okay, so we should have the simplest form of unit test. It is that the component should create at least. Okay, the dummy component should create. So we are writing a test by following it. Okay, and the name for the test that we're going to be writing, and the method what should happen. Okay, so expect, as I mentioned, is something from assert library. Okay, assert library, and what we're going to be asserting, we will be asserting this component to be truthy. To be truthy means it should be true. It's not should be undefined. It should not be null or something like that. We should make sure this component is get created. Okay, if this component get created, of course you can proceed on. Otherwise you will get an error. Okay, so we will write our own test in here. So let's say what we're going to be testing. Yeah, we'll try a simple test. Let's say we will add a method add. Okay, and we will find integers. Let's say a number, right? So yeah, number, b number, and we should return a plus b. Okay, this is a very basic method. Okay, So we will be testing out this one for starters. So we can say it should, okay, it's normally when we are writing, we say it should, what it should be doing. Normally that is the convention that we follow. It should give 5 when we give the condition as much as possible in plain English, when 2 plus 3 is given. Okay, that's depending on your language of choice, but normally try to follow a pattern. Normally this kind of pattern is common. It should give 5 when 2 plus 3 is given. 2 and 3 most probably. All right, and we can say expect component dot add number, let's say 2 plus 3 equals 5. Let's see whether this test runs. Format document. We can run individual tests. Let's see what we'll get. Yes, it should give 5 when 3 and 2 is given. So we know that okay, this logic is perfectly working fine. Let's give it's a common practice when we are writing a test case. It's common practice to test a negative scenario as well, because sometimes the method implementation can break. Method implementation break will certain scenarios. So we normally test a negative scenario as well, and some huge numbers, some smaller numbers. The more tests you have, more your method is solid. Okay, it should give it should give it should give error, or it should return n, not a number, when 2 and undefined. I think I can't give undefined in here. Undefined is given. Okay, now I think I can't pass undefined because it is not undefinable by the add component. Maybe let's come up with something else. This method, I don't think that that can be happened. Any other test case, a good case? It's not customary to give the same kind of thing, and if you give something like that -1 and this kind of thing, it should it's not an n. Let's see. Okay, we can give something like that. Let's run this and see whether it is failing. It should fail. Yes. So you can see that expected 5, but received 1. Okay, so it's true because 2 minus 1, it is -1, and we assume that it's going to be 5, but that is wrong. So we can say equal 5, or we can say not 5, not equal, right? Not oops. To be not equal 5. Not equal. to be none, to be undefined, to be defined. Okay, so let's say to be greater than -3, -2 or something like that. Should work, right? Let's run it. And yeah, it runs. You can run the whole suite if you like and check whether all these things are running. Okay, it should run. So these are like very fundamental basics things. Okay, but these are not like real legit cases. So we will try to go with more advanced one. Okay, more advanced one will give you some context on how these things are affecting our um, coding standards as well. So this is like a very basic one. We are adding two numbers and giving it away. So one other thing that I would like to see that, as I mentioned, the decomposition of methods. Let's see how we can do such a scenario. Okay, we need to come up with a method that is complex as well as testable. Okay, so let's see how we can do something like that. Let me get a very complex method. I had one in here. Oops, sorry. Terminal. Is that actually? Okay. So our method of choice is gonna be our method will be remove product. Okay, public. We will create an array first. We'll have a class to simply gain some experience. Interface, we have product. Okay, it's simply gonna be only a name's gonna be there. Instead of product. Okay, we'll have an array of products. Products, and it's gonna be product array. Initially, it will have nothing. Okay, we will say public remove products, and we will give a name to remove it, and that's it. And how do you gonna code this method? Let's simply go with how we're gonna do that. So I need your input. So based on your input, I will be doing the code. Okay, so we will be removing a product when we give a name. So how are we gonna do that? Yes, I need your input so I can you guys are involved as well. Yes, let's discuss. Supuni, how are we gonna remove a product? What is your approach on here? Yes. Supuni. Hello, Subini, you can hear me, right? Okay. 004? Can't actually. No, no unit.
So we can use a filter method there.
Okay, we'll be using a filter method. You can say this dot product dot filter. Let's say p dot name equal, and we can say this dot products. Okay, correct.
It should be not equal sign, right, sir?
Okay, not equal. Whatever the not equal name, it's going to be removing the product. Okay, let's go. So uh, we are saying, okay, let's have a set of products and we will filter out by the name that we have given and it should work. Yes, correct? Yes, correct or not? Okay, let's write a test case and see what we can get from this one. I will copy. It should remove. It should remove. It should remove. We'll give a name. It should remove monitor from products. Okay. So what should happen is we can say first we know the component. Okay, component dot remove product, and we say monitor. Okay, and what's to be expect component dot product. Okay, within the product, what is the expected use case in here? To contain, right? To contain monitor. To contain not. Sorry, to not contain. Let me give a second. Just not contain. Okay, not contain like this. So this is your test case, right? Let's run it. Yeah, it works, right? So it should not contain monitor within here. Okay, that is working. Let's do more testing and see what should be there. Okay, so we will have initial component dot products equals something like this. Let's say monitor and monitor. Okay, there is no restriction. We are having something like this. Okay, we need to be a product. Okay, that's how monitor map. We say yes, and we can say new product. We have to export the product. Export product. Product. Yeah. Exporting this product. Yes, right. Let's oops. One for name product. Okay, we have imported it. New product. We can just simply use an interface. We can say name. Yes, I can simply say name. In here, it's a name. So you don't have to put it in here. And data type should be different. That's why it's as product array. Yeah, sorry. We need to come up with product array. Okay. Say product. Product array. What is giving it wrong? Okay, let me put in like this. Const products. And it will be product array. Can just create two products. Name, monitor, something. Name, monitor. Okay. So what we have done is we have created one called monitor and another one called monitor, and within the product component we have assigned the new created products, and we have created the remove product, and it should not contain the item called monitor, right? That's easy. Let's run this again. Yeah, pass again as well. But now if you do something like this, let's say, I'm not sure. Now we have monitor and we have TV. It should now, after removing monitor, it should contain TV. TV should be there, right? Because we removed only monitor, and we should have TV in here. Let's run this. Okay, first thing first, we have done received an array. So we are providing a product array, but we are checking for name, so it's wrong. So we have to say name TV. Okay, this should work in here as well. Expected value is name TV and received an array of name TV. So this is wrong. This should all should be changed as well, because we are giving a name, but we are expecting an object. Okay, let's try to run it again. To contain, check whether it is equal. Okay, I think we are using the wrong method. Let me check. What is the best way? Just array contains. Following test. To contain object. Okay, let's say to contain. Okay, no, to contain object is created one. Expect product to okay, we have run different test. Expect to equal. Let me run it again. To equal expect array containing object, expect object containing name TV. Okay, this is how we have to check, unfortunately. Let's see whether it is also correct. Let's run it again. It should remove monitor and have TV. Oops. Let's run it again. Okay, it should remove monitor and have TV from the product. So a little bit difference that we different that what we have written so far. So we are expecting the component product variable to be equal. Okay, to be equal. We are expecting array containing. Okay, array containing what? Expect the object containing this value. Okay, it's more like we are going through the array and we are expecting this to be there. Okay, containing object. So we can write more in here. So let's say we have removed monitor and TV, but we have another one, like let's say iron. Okay, and we run it again. Let's see how it goes. Yes, it should also work, because even though we added iron, it is also there. Let's see if we want to have 2, and we can say iron in here as well, and we run it again. Yeah, the test is also passing. But if we change the name with something that is not there, let's say monitor. Okay, that means we are not removing something that we are not supposed to do. I mean, we have called the remove product monitor. Then again, the monitor should not containing in here. Okay, but we are giving a false input here. It should not pass. Yes. So you can see that we are checking the products. Okay, we are checking the array, and that array should contain object contain TV, object containing object containing monitor. But as you can see, we have removed the monitor, so it should not have, so the test case fails. Okay, so this kind of things are common. Let's expect not object containing monitor, whether it is correct. Yes, as you can see, you can achieve this method by writing different type of tests. Okay, it's really simple, really easy. If you get the hang around it, it took me like 3 to 4 months to understand this syntax, understanding the testing behaviors, and understand everything. So it will be a little bit complex at the beginning, but when you get used to it, it will be really simple. Okay, so this kind of test is actually can be considered as very simple. Okay, so we have a set of products, and we remove one product, and that product should not be containing or should be there, and we can write other test cases like did it introduce anything, like for example, let's say phone. Okay, for some reason the phone is executed. Okay, now it is giving an error. Okay, if we remove it, the phone should not be something that is coming on. Okay, so you can more than myself, a tester, they have a set of instructions or set of testing mechanisms they execute on these test scenarios. So if you can consult someone who has more testing experience, you can ask them on a different type of test. I mean, different way of testing. I'm not that kind of expert on this, but a basic idea that you can get to get around or get trying to run these kind of tests. So basically, when we are writing these test cases, remember these tests are something like responsible of the developer themselves. Okay, so you can't understand, you can't expect these test cases to be written by someone from the testing team or QA team. This will be your test. The unit test most of the time is written by the developer themselves, because they know the code, they know the testing scenarios. But testing different scenarios, of course, you can take advice from other people, and you can write so many test cases. All right, let's make this more complicated and see whether we have done something breaking changes or something like that. So for example, when we are removing product, we will call another method public. Let's say the method is remove. By removing product, we will say send email. Okay, email should be sent if you have removed this. Okay, by calling the name. Okay, for now, we will not be like doing something else, but we will console log say send email on removed product, and we will just have the naming. Okay, but in real scenario, what should happen is there's HTTP call or something going on there. But in our test case, what we are interested in is we are calling this method within our testable method. Okay, so when we are writing a test case, make sure you are writing a test case for this. And when we are writing a test case, we need to check this is also working. Okay, since this is a line of code that containing containing operation, we should have this send email as well. So for example, let's assume that we were doing a bad job. We were doing a bad job. That means we are trying to call the we are trying to execute whatever within the sent email within our application as well. Okay, we will do something like this. Send email. We will have send email array for demonstration purpose. Okay, we will say product, and we will have this. So within the sent email, what we'll do is we will simply push the sent product into that array. Okay, so when we want to send email, what we'll do is this dot send email. Then we will say send emails. Let's say this send emails. Let's say push the product, in this case name. Okay, so what we have done is in a hypothetical manner, when we are removing the product should be filtered. Next thing is we should send an email. In this scenario, we are simply pushing a value to the array which is there. Okay, so so now we have two functionalities to test. We need to test the product, whether product is getting filtered or not. The next thing is sent emails is getting populated or not. Okay, there are two functionalities. This one is updating and this one is sending. So if you try to write a unit test, it will be from this scenario, seems to be easy. Okay, but believe me, when the complexity of this email sent, okay, we are just pushing a value there, so we can easily check something like that the sent email has this new value or not, or something like that. But in reality, the sent email function will be much more complicated. It will have HTTP request to make. It might take some validation to be happen, and there is going to be a lot of things. So we can say, for example, we can only do this if name not equals empty, then we can only push this email. Okay, that is the email logic. If we are doing that, we can only do if the name is not this, or we can we might have a separate logic saying, okay, name not equal internal. Okay, we don't send a product name internal. If it is not equal to internal, then we are sending a mail. Okay, now what you see is the complexity of testing this remove product is getting more complicated. Okay, so if you want to write a test for this code section, at least we need to test. We now have a good test for testing this section. But when we want to test out the email sending functionality, now it's a little bit complicated. Okay, now if you write a test in here, the test will be a little bit awkward to test, and it will be really hard to read, and it will be really hard to maintain. Okay, so in a situation like this, the best thing that you can do is, okay, you can clearly see a difference, or clearly see a business logic that is overlapping, or that is completely independent from the remove product, and it is growing complexity. So what we can do is, rather than testing out this functionality in here, we can put it in a separate method and call that functionality. Okay, now we can test the send email method different in a different test suite or maybe test section, whatever you like. Okay, so for example, we can create a test suite for here. Describe. We can name this as remove products. Okay, and within the remove products, we can put all these things that we have done so far, including here. So this describe section right around here. Okay, now if you want to describe if you want to test something like send email, and you can put your test in here. Okay, it should send email with whatever you like. Let's say send email for let's say the value is like not internal, let's say TV. Okay, so in this scenario, the method what we are going to be testing around is going to be simple. So we have the component and we will have the send emails, and we can we can expect, sorry, we have to say component send email, and we have to give a product name. Let's call it TV. Then the next thing that we can expect is component dot send emails to contain, actually it should be something like this. If I'm being totally careful, to equal array containing, and should be send emails, and it should contain T. Okay, now if you run this, yes, it should pass. Now you can see the tests are grouped. Remove products we have skipped, and send email is also working. And we can test the other scenario that we have described. It should not send email internal, because we are filtering out in our logic. You can say internal is not allowed. So we can say object in here, it should not contain internal. Okay, it should not contain internal. Yes, that is also true. Then again, we can have some creative ways of doing this. Okay, it should not contain internals, but let's say we create some other products, but those things should be there. So we can say component send emails, let's say products in here, send emails, products is here. So we should even though internals, okay, we can say not like this, but let's say we have sent emails internal as well. So it should contain TV, but it should not contain internal. Okay, it should contain TV, but not internal. Let's run it and see. Yes, these things are passing. Now, if I want to test everything with sent email, I can just run it in here. Since it is a test suite, yes, everything works. Now, you guys can see that when we are writing unit tests, when we are told to run unit test, we automatically divide, or we try to more modularize our code in terms of testability. That's why we are running these kind of that's one of the advantages that we have seen. So if we break down our method into testable components, our methods are shorter. Okay, if it was not we are not focusing on unit testing, this logic will be in here. So it is harder to read now. It is simple, at least, not like that, not like what we can read right now. Okay, if you are removing product should be filters, and you will have to send an email. Okay, like reading English, it should be able to read the code itself. Okay, so now we have introduced a dependency in here. So we have to make sure that when we call the remove product, okay, this thing happens, and we need to make sure this is also happening as well. Otherwise, it is a wrong doing. Okay, our remove product method not only focusing on filtering out and showing this stuff, but also it should call this send email method. Otherwise, what will happen? We are only testing a portion of our code, only this one. Now we have to test this one as well. So we have to write another test case to make sure this method is executed. Okay, this method get executed. So what we can do is, within the remove product, we can write another method or test case. It should call send email. Okay, it should call send email. So this is one of the things that we are supposed to expect. Okay, so we will be calling remove product from monitor. Now we have to make sure the send email method is invoked as well. So this in here, at this point, we are working on something called spying on. Okay, so spying on, as you guys can remember, we can't test anything related to this method. Why? There are within this remove product, we are testing only whatever within this method only. That's the rules of unit test. You are not allowed to go beyond the boundaries. Sorry, beyond the boundaries. Okay, so you cannot write anything that will be testing around here. Okay, you can't assert and check the send email. Send email is like what we have done here. We can't expect the array to be something like this. Let's say, for example, we copy this, and I'm doing the wrong thing here. Okay, so array should containing monitor. Okay, so this is working, should work, right? Yes, it should work, but we are doing something wrong. That is, we are tampering with something out of this method. Okay, this method is only about product. We are testing something from sent emails as well. So we are tampering with something else, but it is working. It is true, because we call the remove product in our method. Remove product will call the send method, and send method, if they don't have any logical error in here, and it will push to the array, and we can check on the array as well. But as I mentioned earlier, we are going out of our boundary in here. So we have to keep our boundary intact. So what we're going to do is, we are not going to check the logic in send email. But what we'll do is we will check whether it is invoked correctly. If it is invoked correctly, then the boundary of that unit test, it is over. We don't have to worry about it, because there are several test cases specifically written for send email that will do their job and check whether it is executed or not. Okay, right now we don't have to worry about that. We just need to check whether method is invoked. So what we can do is we can check whether the method is invoked or not. Let's see, method is called. Okay, how we can do that mock functioning. Okay, let's see how the mocking is done. Okay. Mock returning value. Okay, just give me a second, guys. Mocking, let's change a little bit. Okay, spice and mocking. Let's see if we can get a spy on here. Should be spy action. Okay, I think I got it. That's great. So we need to do something called spy on. Okay, that means we'll be what do you mean by understand? In general, spying means what we are saying is we are looking, or we are interested in whether this happened or not. Okay, that is simply what spy means. So we're going to be spying on this send method. Okay, so we will be saying, okay, when we are executing this, we will check, we'll spy on this send email method whether it is getting executed or not. So we will be using something called spy in. We can use that jest spy on method. Okay, so what we're going to be spying on, component dot send email. Okay, we will be spying on this method, because within the remove product, it will call this method, and if it is calling, we will be spying on it. Okay, so we will name this as const spy. Okay. Let's see, creating more function. Expect. Okay. First thing, I think it's the component sending. Const spy. Let me see. Video just expire. Arguments not document, please. Const video require videos. Okay. Test spy on. Create a mock function for testing. Okay. Argument type string not accessible for type never. What that means. Let me check. Let's see, object method spy on.
So that send emails is a array, right? Not a method, no?
Sorry, my bad. Send email, right?
Yeah.
Even that it is saying that. Let's say that again. Even not giving that. Normally when we have to call is the method name. What we have done wrong. Send email. Okay. Maybe I sent email, right? It should be send email. Okay, sorry, typo. Const spy. Okay, so we will be spying on the method itself. Okay, we'll be spying on this method. So now what we can do is, now when the remove product is called, we can say expect spy, okay, to be called. That means when this remove product is called, we are expecting this spy, okay, this spy is spying on this send email to be called. This should be called, okay, whether it is correct, let's see. And yes, it is called. And there are some other methods as well to be called. How many times? To be called times. We can say how many times it is called. In this scenario, it is 1, but let's give something like 3. It is a false, right? Then you can see expected number of calls is 3, but we received only 1. Okay, we can say, okay, 1, and then it should be expected to run with this. Okay, expected to send email with ones. And there are even more fine-grained ones to be called with. Okay, to be called with means we can provide what are the values that we are expecting, if I'm not mistaken. Yes. Monitor should be correct. Yes, let's say monitor X and see whether it is failing. If not, yes. So you can see we are expecting to call with monitor X, but we received with monitor, right? Because we can see right now with remove product, if you go to the remove product logic in here, it is sending the same name, and it should be called, or it should be called with, when we are calling this one, it is calling the same name that we are giving. But for some reason we are altering this. Let's say, for example, when we are removing the product, remove plus name. Okay, we will have something like this. remove dollar name. That means when we are calling this remove product when we are calling remove product, and the remove product will call send emails with appending remove and name. Okay, so now it should fail because we call our component with monitor, but we are calling the spy method, send email method, with something different. Now if I run this, it should say, okay, we are expecting monitor, but received removed monitor. Okay, so our test case should be updated, and there you go. Remove monitor. Okay, now it should run, and yes. So what will happen? What has happened in here? We are spying on it. The spying on it is a very good method. Whether we are calling this method or not. Now you guys can see that clearly it's getting more advanced and advanced. You guys get the idea behind why we need these things. Now you can see that clearly calling from some other method, it will change. Okay, in here we are normally directly calling, but in remove product we are having with prefixed. Okay, so the test methods change here and there a little bit here and there. So what ultimately happens is the methods that are more simple and what do you call simple and elegant are getting more complex. So how much complex even the method is getting, now it is proving behind us. Okay, so we don't have to worry. So if I run the whole test suite in our class, it is perfectly working. Okay, now the now there is advantage on this as well. Okay, so for example, somebody comes to our office, or somebody is new to the project, comes in and they don't know about anything with the test that we have written, or they don't know the logic behind it. They get a bug and they are trying to fix that, and for some reason they are saying, okay, from their perspective, they think this should be not internal but internal X or something like that. Okay, so some reason the logic has been changed. They come and fix, okay, this is the error, then they will come and change the logic. But when you go to the production and when we are trying to run the test against it, if we have written, okay, seems to be we have not written good test. So the test coverage did not it did not cover the change that we have done. Now you can see that it is not passing as well. So we should initially have something object not containing internal. Yeah, our test suite is weak in this scenario because some change like that should not allow our test to pass. So we are missing some test cases, and we should write those things as well. So, but in general, theoretically, let's say let's non-case, we say removed. Somebody came and say removed instead of remove. Now if I run this again, and yes, you should say, okay, there is an error. What you are trying to do, it should call send email with removed, expected remove, but we have say removed. So the main reason of writing unit test is we know the errors before we go to production. Okay, you can't find the email service not working because somebody came here and add a simple T. Okay, before we have, after we have done some changes, make sure either the test case should get updated. Okay, the case should get updated because of the logical update, or you are doing something wrong and you have to make sure that test does not fall in anywhere else. Okay, so these kind of tests are only limited within the project itself, but it is not not project is the component itself, but it is not reflecting all the things within the application, because writing a good code, okay, is all about making these smaller adjustments. Okay, from my points on writing a good method, if you have a method that is exceeding more than 20 lines of code, you are doing something wrong. Okay, you are not either you did not get the requirement, or either you did not break it down into smaller pieces, or either the logic is too complex. Okay, so you, as a thumb of rule, make sure when you're writing a code or something like that, it does not exceed a certain amount of values. Not like 1,000, that is like extreme value. At least 20 to 30. If you can justify it, that is totally okay. But if you can't understand, you can set up, you can point a finger on it. Okay, this should be lower than this, then there is something wrong with the application. It will certainly break in the future, and it will be certainly not testable. So make sure you write your code as much as smaller pieces. That is okay. Containing thousands methods in a project, that is totally okay, rather than having a big bulk of 1,000 lines of code. 1,000 methods, perfectly okay. And if you find yourself this component cannot handle this component has too many things to do, export it to a function or export it to another class. Okay, then from there you can test it out. Likewise, it is good idea to have testing separated, testing mechanisms and everything else into separate sections. And make sure the test coverage is good. Apparently our one is very bad in the sense. So when we said email internal X, it should not be containing internal, but supposed to be it also contained. So there is something wrong. We have to check in the code itself why this did not happen. And we have to check ourselves. There is either the test is wrong, either the code is wrong. Most of the time, it's the code that is wrong. So we need to check on this section. Okay, there is something wrong within our case. So that's the beauty of testing. You will find bugs before you even go into production, or before you can imagine. There are some silly things that you will miss. Writing good test coverage will help you definitely to find easy bugs. So rather than finding those things later, it's better to have test earlier on. So if you guys know the terms TDD, test-driven development. In test-driven development, the first thing that you do is come here and write all the test cases and run it. Okay, in test-driven development, you come here and first you write the you have the requirement, you write the test cases first. Okay, test cases in the sense the send email method should be there, otherwise you can't like getting compile error. But send email, and you have to check the first time what you do is whether you, even though there is zero code, you have to run it and see whether it is working. If it is running, then your code is wrong. Okay, you can't run zero implementation code and your test fast, then there is something wrong with your code. Okay, then if it is everything is getting failed, then you write your code. After you completed your code, then again run your test and see whether it is passing or not. Okay, it's a good practice, but it is really hard on in practical life. I mean, you can't get every single detail nailed down to your application. It's change, so it's a little bit hard, but it's a good practice if you can follow. Okay, so we have talked about testing, writing unit test and everything. See, let's see if we can get another session on end-to-end test, all those things. Hopes time you guys have what do you call more time left within your curriculum, or you guys are ready for the examination right now?